Okay, hello everyone. I hope you are safe and sound. No? Before we start, I would like to go through some announcement muna. First of all, na-update ko na yung PowerPoint. No? So please re-download the file kasi may mga dinagdag akong topics dito. Okay, so yung nadagdag is this one, the comparison and the calorimetry. So please re-download the file. Okay, so yan para may updated copy kayo. And the second announcement will be on the schedule of your problem set. I changed the schedule na, no? So supposedly you are going to submit this by Saturday. However, since I want you to focus on this topic muna para makapag-review rin kayo, so minove ko na lang siya sa Wednesday next week, which is March 12. Okay. So yan, so you will have more time, but again, I am expecting that you will work collaboratively with your classmates, okay? Kung may work yung classmate nyo, sabihin nyo lang sa akin, maunawaan naman natin, no? Kung bakit matagal siya mag-reply, hindi siya makapag-collaborate. However, if your classmate isn't working naman, okay, so wala naman siyang responsibility to assume na siguro I will expect you to help your classmates. Kumbaga, atong prob sets naman natin na groupings, no? It serves as your reviewer as well. Okay? So, review nyo rin to as a group, no? Para sa upcoming quizzes and later on sa examination. Okay? So, I want you to utilize this, the purpose of groupings, no? Para makapagtulungan kayo, no? Para alam niyo yung mga gagawin nyo sa mga problems. Okay? So that kapag nag-quiz na kayo, most likely mataas makukuha yung score. Okay? So hopefully, tulungan nyo yung mga kasama nyo. Okay, kasi I'm hearing some words that yun nga, na medyo may ilan na hindi nagpaparamdam, kailangan patakutin. Okay, so yan. Again, kung may work kayo, no, just let me know, no, para mabibigyan ko kayo ng consideration. Okay, however, if wala namang work, no, then maybe you can join your classmates, no. Okay? So, ganun lang. Kapag meron namang health-related concern, just let me know as well, okay? Para ma-consider din natin, okay? So, nadadaan naman yan sa usapan, okay? So, just let me know kung ano yung dahilan, bakit hindi makakatulong, no? Okay? Tsaka, another thing is that most of you ay honors. Alam nyo yan, no? Most of you ay honors. Kaya, I'm expecting higher level of, um, integration with your friends, no? So, medyo high level dapat yung ating activities, no? Meaning nun, hindi lang dapat tayo susulpot kapag magjo-joke time, hindi lang tayo susulpot kapag mag-ML, no? So, kailangan nagpapakita tayo din sa mga groupings, no? Majority of the students in PUP are PL and TL this last semester. So, I am expecting that you um, you will prove to me, no, na PLDL talaga kayo. Okay? Kasi ako mismo, I earned my honor, no, nung college ako. Na-earn ko yung honor na yan by, too much effort. Okay? Kaya I am expecting that you can also exhibit that effort. No? Okay? So, again, if you have any valid reasons for not being able to participate, then I can consider it. Just let me know. However, if wala naman, then maybe go participate na. No? Okay? So, review nyo na rin to para sa inyo rin yan. Okay? So anyway, pag-usapang deadline naman maluwag ako. No? Pwede ko i-adjust yan anytime. Okay? Provided that makita ko na the circumstances quite tough for everyone, then I can move the deadlines. Kaya nga walang deadline yung quiz eh. End ng SEM yung deadline nun eh. Okay? So yun lang. Again, yan updated na yung ating PDF. So please re-download that. And yung ating deadline ay updated na rin for the quiz. And of course, join your classmates when they are working collaboratively with the problems. Okay? So, Now, let's go back to our main topic for today, which is the continuation of thermochemistry. Okay. So, last time, mag-review muna tayo. Last time, ano meron? We just defined internal energy change as the sum of kinetic and the potential energies. However, obtaining the actual kinetic and potential energy of a system is quite impossible to do because you have to consider everything. Okay? Which is impossible for us. No? Hindi natin pwede ma-measure lahat. No? Kasi we are humans. We are bounded by our limitations. So that means we have to devise another way to get an idea how much is the internal energy of a system. Okay? So, using our example, nakakuha tayo ng another way to get delta U, which is the sum of the work and the heat. Okay? So, work, you know that? Yan yung displacement, no? Force times displacement according to physics. But in chemistry, ang equation ng work na gusto natin is the negative P delta V. Okay? So, dinerive ko yan last time, di ba? Negative. So, work is negative P delta V. Okay? So, yan yung equation natin sa work. We can integrate this. Pwede mo integrate yan to get negative nRT ln Vf over Vi. Okay? O kaya nRT ln Vf over Vi. So, positive, negative kapag expansion, positive kapag compression. No? So, ganun lang. And then, meron tayong reversible, irreversible. So, meron tayong P delta V lang. Meron tayong P delta V na negative, no? So, yan. So, na-discuss na natin yung work, no? So, ngayon, pag-usapan natin yung isa pang component ng internal energy, which is the Q. Okay? So, yun yung main topic natin for today. Medyo mahaba yung usapan for Q. So, kapit lang. Okay. So, let's start. Enthalpy. Okay. So, bakit tayo napunta sa enthalpy? Ang usapan natin ay Q, no? Ganito kasi, dito natin makukuha yung equations for the Q. Okay. Anyway, so remember the first law of thermodynamics, which we stated that the internal energy change of a system is the sum of the heat and the work, no? And we defined work last time as delta U equals Q minus P delta V. Okay? So, define natin yan last time eh. Okay? If I write it in differential form, then I can write it as du dq minus P dV. Okay? So, yan. Now, we have to consider two experimental setup, no? When doing chemical experiment kasi, you can either do that in a constant volume or constant pressure. Okay? So, pwede mo gawin ang isang chemical experiment in a constant volume process. O kaya, pwede mo siya gawin in a constant pressure process. Okay? Pag sinabing constant volume, looking back at our equation dito. So, looking at this equation, if we have a constant volume, what will happen to our equation? This equation will be mawawala to. Diba? Ngayon, zero yan. Why? Remember, delta V means change in volume. Pero pag sinabi constant volume ang experiment mo, fix yung volume niya, hindi yan nagbabago. Ibig sabihin yun, zero yung work. So, as a result, the internal energy change is the heat na, no? Okay? So, yun na yun. The internal energy change is the heat at the constant volume. Okay? So, ganun lang. Ngayon, punta naman tayo sa next one. If we have a constant pressure process, ito yung typical na ginagawa sa laboratory. Yung constant volume, medyo mahirap yung gawin eh. Kasi when we are doing chemical reaction, kailangan fix yung volume. So, you really have to monitor that, which is so hard to do. Ang makaya gawin sa laboratory na madali lang, no, is the constant pressure. Bakit? We are surrounded by a constant pressure, no? Yun yung atmospheric pressure, which is 180 m. And so basically, whatever we do ay generally considered na constant pressure yan. Okay? So, yan. So, if we have a constant pressure process, what will happen to our equation? Let me rewrite this. Delta U equals Q minus P dV. So, if we have a constant pressure process, what will happen? Wala. Ayan pa rin yung equation natin. Okay? So, ganun pa rin yung equation natin. So, we have delta U equals Q minus P dV pa rin. Kasi remember, dito sa equation na to, constant na yung pressure. So, wala na tayong ibang gagawin. Okay? So, ayan. So, we have du equals Qp minus P dV. By the way, take note of the subscript. No? Pag nakita nyo QV, constant volume yan. Pag nakita nyo QP, yun ay constant pressure. Okay? Just to differentiate the two forms of heat. No? So again, take note that at constant volume, the heat is the internal energy change na. At constant pressure, the heat is the, ayan, yung entire equation na yan. So let me rewrite it. So that can be written as delta U plus P delta V. Okay. So, yan na yung equation natin for Q. Pero, hindi pa rin natin nasasagot, no? Paano natin malalaman yung Q? Okay. So, for them, no, for the scientists, no, to determine how to measure Q, they defined another energy form, no? Nag-define sila ng panibagong enerhiya, no? Tawag doon ay enthalpy, no? So, according to enthalpy, according to the scientists, they defined enthalpy as the sum of internal energy plus pressure times the volume, or H equals U plus PV. Okay? So, if we take the derivative of this, ano pwede mangyari? Kunin natin yung changes. Kunin mo yung derivative niyan. So, you have dH. The derivative of U is du. Okay? And the derivative of PV, anong gagawin mo dyan? Quotient rule, no? So, the derivative of PV can be written as P dV plus V dP. Okay? So, yan. So, ano lang yan? Quotient rule. Then, what's next, no? So, remember that majority of chemical reactions happen at constant pressure, no? So if we apply that condition in our equation, applying constant pressure, what will happen to the equation? May mawawala dyan yung ito. Mawawala yan. Why? VdP. V times the change in P. No? V times the derivative of P. And if constant ang P mo, what's the derivative of the constant? 0. Okay, so mawawala yung term na yan. So therefore, we can write this as dH equals du plus P dV. O kaya, pwede rin yan isulat as delta H equals delta U plus P delta V. Pero kanina, di ba, sinabi natin, balikan natin, sabi natin Q is U plus P dV, di ba? Delta U plus P delta V. Okay? So, ibig sabihin, kung yun ay, ito rin yun, di ba? Yan yung QP. Ibig sabihin nun, yung heat at constant pressure is the enthalpy of the reaction. Okay? So, ganun. So, we just derived that the heat at constant pressure is the enthalpy change, no? Or QP is equal to delta H. Ngayon, paano mo malalaman yung delta H ng isang reaction? Generally, given yon. Okay? So, generally given yan. Okay? So, medyo wala tayong magiging problema dito. If hindi yan given, then pwede tayo mag-derive. Okay? So, once na mahanap mo na yung delta H mo, given kasi yon, minsan hindi given. Pag hindi given, derive mo siya. Pag nalaman mo na yung delta H mo, pwede mo na makuha yung delta U mo. Okay? So, ganun lang gagawin natin dito. Okay. So, alam na natin mag-solve ng work eh. So, alam na rin natin yung delta H. So, ibig sabihin, kaya na rin natin malaman yung delta U. Okay? So, ganun lang. So, again, delta H generally given yan. Okay? Siguro you may ask yourself, paano naman po, sir, ito? Paano po ito? Paano yung delta U? Kung at constant volume, paano mo makukuha yan? Okay. So, discuss natin yan sa dulo. Okay. Paano siya makukuha? But for now, let's focus on constant pressure because again, almost all chemical reactions happen at constant pressure. No? Okay. So, yeah. So, now alam natin that Q at constant pressure is delta H, which is generally given. If not, you have to derive for it. Okay? So, yun yung gagawin natin. Okay. So, for any reaction, the change in enthalpy is called the enthalpy of reaction. Okay. So, that is the difference of the enthalpy of the product or the energy of the product minus the enthalpy of the reactant or the energy of the reactant. So, if your enthalpy change is negative daw, again ay negative, we have an exothermic process. And if we have a positive delta H, we have an endothermic process. Okay? So, ano implication nito? For example, you did a chemical reaction, tas na-feel mo uminit siya. Exothermic process yun. Medyo similar siya sa Q, no? Diba sabi ko, kapag Q is negative, exothermic. Kasi nga, sabi natin, Q is delta H at constant pressure. Okay, so kapag lumalabas yung energy in the form of heat, delta H is negative, meaning non-exothermic ang process. Umiinit yan. But if ang energy is inaabsorb ng system from the surrounding, then Q or delta H is positive. Then that's called an endothermic process. Okay? So again, we can interchange Q at constant pressure and delta H because we just derived for their relationship earlier. So now let's proceed. So generally, we have a chemical equation written here. So for example, this is the combustion of methane in the presence of oxygen to reduce carbon dioxide and water. It has a corresponding enthalpy na. No? So pwede mo na malaman yung heat ng reaction. Okay? If we have an equation with this chemical equation sa gilid and the enthalpy change sa kanan, we call that a thermochemical equation. Okay? Ibig sabihin nun, sinasabi niya yung amount of energy that can be produced by this reaction. Okay? So, generally given yan. Okay? By the way, these are some things that we have to consider when we have a thermochemical equation. Una, you must always specify the physical states of all reactant or end products. No? Kailangan sabihin mo, siya ba ay solid, siya ba ay liquid, siya ba ay gas, no? Because later on sa discussion natin, magmamatter yan, okay? So you always have to state kung anong form yan. Solid, liquid, gas, or anong uri siya ng matter, no? So, ganun. Okay, pangalawa, if multiplying both sides of thermochemical equation by a factor n, the delta H must also be multiplied or must also change by the same factor. Ibig sabihin yan, if itong equation na to, i-times 2 ko, kung ita-times 2 ko yan, yung delta H ko ay times 2 din. Okay? Times 2 din yung dami ng energy kasi dami mong dami mong chemicals, dami nagre-react na. Ibig sabihin nun, times 2 din. Kunwari, i-divide ko yan by 2. So, ibig sabihin nun, yung delta H niya, divided din by 2. Okay? So, divided din yan by 2. Kasi nga, minultiply ko yung equation by 1/2. No? So, ibig sabihin, the delta H should also be multiplied by 1/2. Okay? So, basically, kung ita times 2 mo yung equation, times 3 mo yung equation, i-multiply mo rin yung delta H. Pag dinivide mo yung equation, divide mo rin yung delta H. Okay? What else? In writing the reverse of the equation, your delta H will also be a reverse. So, kapag binaliktad mo daw yung equation, babaliktad yung delta H. Ibig sabihin nun, yung reactant pati product, pinag-switch mo sila, yung delta H, magpapalit siya ng sign. Hindi yung number yung magpapalit Baka kasi mamaya gawin nyo, 4098 yan. Mali yun. Yung sign lang yung magbabago. Okay? So, for example, itong equation na to, I will do the reverse. Sulat ko yung reverse niya. So, yung product, lalagay ko sa reactant. Okay? Lagay mo yung states. So, ang delta H niyan ay babaliktad ng sign. Okay? So, kung kanina, negative yan, ngayon, ito ay magiging positive. Okay? So, that will now be positive. So, important to later on. So, important to, kaya take note of that. When you multiply the equation by 2, delta H should also be multiplied by 2. If you divide the equation by 2, delta H should also be divided by 2. And then, if you reverse the equation, then you have to reverse the sign of delta H. Kung positive yan, binaliktad mo, magiging negative yan. And kung negative yan, binaliktad mo, magiging positive yan. Okay? So, yun yung mga kailangan mo i-take note. Okay? Okay, so for example, if we have a chemical reaction of sulfur dioxide reacting in air to produce sulfur trioxide, how much heat daw is evolved when 87.9 grams of SO2 is converted to SO3? Okay. Alamin natin kung gaano karami yung energy. Okay. So, ang gagawin mo dito is ganito. Yung delta H kasi, this is relative to the moles of the chemical equations natin. That is dependent on the moles of your substances. Kaya nga sabi natin kanina, kung ito times 2 mo yan, ito times 2 mo yan. Okay? Kung divide mo 2 by 2, divide mo yun by 2. Okay? So, may dependency ito, pati ayon. Okay? So, pwede tayo gumamit ng stoichiometry dito. Okay? So, masasabi natin that is the energy. Oops. So, delta H is equal to that if you have 2 moles of SO2. Also, delta H is equal to that value if you have 1 mole of oxygen gas. And delta H is equal to that if you have 2 moles of SO3. So, kung ito times 2 ko yan, ito times 2 ko rin ito. Ito times 2 ko yan, ito times 2 ko rin yan, times 2 ko to, times 2 ko yan. Okay, so dependent yung delta H sa dami ng chemicals mo. Okay? But now, ang given sa atin is mass Mass ng NO2 yung binigay sa atin. Ang alam natin, yung delta H, related siya sa moles, hindi sa mass. So, ibig sabihin, we have to convert the mass into moles. No? So, yun yung una mong gagawin muna. So, you determine the mole of SO2. That is the mass SO2 over the molar mass SO2. So the mass is 87.9 grams and the molar mass is given 64.07 grams per mole. Okay. So let's divide that. Round off na natin. Okay lang naman sa akin mag-round off. Hindi naman tayo masyadong strict. So, the moles of SO2 is 1.37 mole. And now, we can do ratio and proportion. Okay? So, sabi natin, if we have this amount of heat, we have 2 moles of that. No? We have 2 moles of SO2. Pero what is the heat if we only have 1.37 moles? We can do ratio and proportion. Okay? Sabi natin, remember that in this equation, delta H is equals to 2 mole SO2. We can use this relationship to convert this into energy. You can use that. We can use this mole. We can use this relationship para ma-convert yon into energy. Okay? So how? So solving for delta H. So sulat mo, ilang moles meron ka? Okay, so you have 1.37 moles of SO2. Then sabi ko, kailangan mo i-convert yan, no? By doing ratio and proportion. So parang nag-ano lang tayo dito na convert na. So ito, i-convert natin to delta H. And this is the conversion factor. Okay? So let's multiply this by the conversion factor. Yung nasa baba, yung mole ng SO2. Kasi gusto mo makancel yung mole ng SO2. So that means yung nasa taas is the delta H, which is negative 198.2 kilojoules. As you can see, the mole SO2 will simply cancel out, and the remaining unit will be kilojoules now. So let me multiply that. So the energy, if you have 1.37 moles of SO2 only, will be negative 135.77 kilojoules. Ito na yung energy, no? This is the heat evolved when only this amount of SO2 is used, no, in a chemical reaction. Okay? So, ganun lang. So, basically, sabi ko sa inyo, yung delta H, dependent yan sa moles neto. Kung marami kang moles neto, mataas yung energy. Pag maunti lang moles mo neto, mababa energy. So, ginawa natin, nag-ratio and proportion lang tayo. So, if this is equal to 2 moles, how about this? Saan siya equal? So, gawin mo, convert mo muna to into moles. Then, later on, you do conversion. So, from this, convert mo siya to energy using the relationship we just established. No? That the mole of this is equal to that. Okay? So, that's how we get the heat evolved now for a given amount of substance. Yan na yung Q niya. So, pwede mo na yun i-plug in. Yan na yung Q eh. Pwede mo na yun i-plug in sa delta U. Na, galing na. Now, let's try this. So, let's try this. So, we have white phosphorus. Let me look up lang sa kanyang molar mass. Hindi ko pala nalagay. Google nyo na lang, P4 molar mass. Okay. So, if we have 266 grams of white phosphorus, and this is the thermochemical equation, hanapin mo daw yung heat na. So, ano yung process natin? You convert mass to moles. Then yung moles, i-convert mo to heat. Yan yung flow natin, no? Okay. So, let's do that. Okay, so we have 266 grams of P4, white phosphorus. So, we need to get the mole of P4. That is the mass P4 over the molar mass P4. The mass P4 is 266 grams. The molar mass of P4 is, according to Google, 123.90. So round off. So this is now 2.15 moles. Okay. So if you have 2.15 moles of P4, what will be the delta H? What is the heat? No? What is the QP? You can use conversion. So delta H equals 2.15 moles. Establish tayo ng relationship dito. Sabi natin delta H equals 1 mole of P4. That's according to the equation. So if you have 1 mole of this, ito yung energy niya. Okay? Ito yung heat niya. So use this equation to convert this. No. So you have 1 mole of P4 sa baba. And the delta H is, ilalagay mo sa taas, 3013 kilojoule. And as you can see, the moles of P4 will just cancel out, giving us the final unit in terms of energy. So the answer will be negative 6477.95 kilojoules. Okay, so very easy. Ganun lang, na? So alam mo na yung Q. Plug in mo na lang yun sa equation natin. Okay, so ganun. Okay. So ngayon, yung mga chemist, no, yung mga scientist, mapapansin nila. So, kung gumawa ka ng chemical reaction, makukuha mo yung delta H. No? Ang question nila, is it possible for us to determine the individual delta H? Kasi di ba sabi natin kanina, yung delta H ng reaction is the H ng product minus the H ng reactant. So, is there a way for us to determine ano yung H na to, ano yung H na to, ano yung H nun? Yun yung pinag-iisipan nila dati. But, thanks to science, thanks to chemistry and physics, pwede, no? Pwede mo na malaman kung ano yung value nito. Ano yung delta H niya mismo. Ano yung delta H nito mismo. Ano delta H na mismo. Okay? So, ginawa nila itong tinawag nating standard enthalpy of formation and reaction. So, according to this, no, basically, ginakwento ko na naman. So, if you want to determine the enthalpy of a given substance, yung nag-iisang substance lang, hindi yung chemical reaction. Okay. Kung gusto mo malalaman yung kanyang delta H, no, then we have to use their standard enthalpy of formation. Okay. Kaso ang problema doon is, kunwari, ito, hindi ko to alam. Paano ko masosolve yun? Tatlo unknown ko, tapos ito lang lumabas. Okay, paano ko masosolve ito? Gano'ng karami yan. Okay. So, ang ginawa nila is that they set a reference, no? Always in measurement, may reference dapat tayo. Parang meron silang zero basis, no? Meron silang chemicals, no? Na sinasabi nila na delta H nun ay zero because they just existed. Okay? So, tawag natin doon sa mga reference point na yon ay standard enthalpy of formation. Okay? So, yun. So, basahin natin ito. Substances are said to be at standard state at 1 atmosphere pressure. Okay? And by convention, standard enthalpy of formation of any element in its most stable form is 0. So that means if you see an elemental compound na stable yung kanyang state, no? 0 agad yung delta H niya. Delta HF. No? For example, we have oxygen gas. What will be its delta HF? That will be 0. Okay? Kasi oxygen gas is in elemental state, no? Yan yung pure form ng oxygen sa nature. Oxygen gas talaga. So, ibig sabihin, siya ay nasa pure state. No? Elemental state siya. So, ibig sabihin nun, its formation is 0. Okay. siya yung reference natin. Our example with the hydrogen gas, the delta HF of this is also 0 kasi it is in elemental state. So since we now have reference, may 0 basis na tayo, then we can determine the delta HF of other compounds. Okay? Kailangan lang natin dito, may 0 tayo. Okay? So we can know the others. Okay? So ibig sabihin, for this reaction, this is elemental state, so 0 yan. This is also in elemental state, so 0 yan. That means kung ano tong energy na yan, that corresponds to the energy of formation of this compound. Okay? Yan. So, ganun lang ginagawa natin dito. Magsaset lang tayo, sino 0? Ito 0 to kasi elemental state yan. Ito 0 to elemental state kasi yan. Ibig sabihin, whatever the heat of the reaction is, yun na yung delta HF niya. Okay? So, ganun yung gagawin natin dito. Ayun nga, sabi ko kanina, if you have a chemical reaction, the overall enthalpy change is the products minus reactants. Nakwento ko na to kanina. So the enthalpy change of the reaction is the enthalpy of the products minus the reactants. So this is the equation. Okay. And yun nga, we need to establish the delta HF, no? So we can have a reference point, no? So basically, kailangan mo i-establish sino yung mga 0 para malaman mo yung ibang species, no? Okay. So there are two ways to determine the enthalpy of formation of other compounds. First one is the direct method, wherein you create your compound from elemental states, no? Okay, take note. In direct method, you are creating the compound from the elemental state. No. Okay. So for example, we have this compound. We have this reaction here. Carbon, graphite, plus oxygen gas producing carbon dioxide. Apparently, carbon graphite is elemental state. Yan yung elemental state ni carbon. Yan yung nasa lapis nyo eh. Stable yun eh. Okay. Yan din yung nasa uling, graphite. Okay. So, ibig sabihin, yan yung elemental state ni carbon, uling. O kaya yung nasa lapis. Ang oxygen gas naman, ito, elemental state niya is gas. No? So, ibig sabihin, kung ito ay 0, ang kanyang delta HF, ito ay 0, ano value niyan sa tingin niyo? Ang value niyan ay kung ano na to. Okay? Kung ano yung delta H ng reaction, yun na yung kanyang value. Kasi nga, sinabi natin, ito 0, ito 0. Bakit? Kasi nga, sila ay elemental state. Nag-reference tayo. Okay? So, yun ang ginawa dito. So, if you have this reaction, we can write the delta H reaction as the product minus the reactants. Since we said that for carbon graphite, 0 yan. For oxygen gas, 0 yan. So that means whatever the heat of the reaction is, that corresponds to the delta HF of CO2. Okay? So yan. Okay, so ngayon, let's proceed. By the way, by doing that, ito yung ginawa nila, gumawa sila ng maraming chemical reaction, so they were able to get this table. So in this table, you can see the standard enthalpy of formation of many compounds in units of kilojoules per mole. So ginawa na nila para sa atin. Okay. So ayan. Okay. Okay. So basically, you can just look up dito sa table anong kanilang enthalpy of formation. So from those, you can get the delta H of the reaction. Okay. So if we have an indirect method naman, ibig sabihin, you cannot synthesize the compound from elemental state. No? Okay, so ibig sabihin, you have to synthesize the compound from other compounds pa. So ibig sabihin nun, the delta HF will not be equal to 0. No? Kasi hindi mo siya kaya gawin from elemental state na. So, 0 yung kanyang so I mean, hindi zero yung delta HF ng ibang compound na. So, kung ganun yung process natin, we have to do what's called the Hess's law. Okay? Sabi ng iba, Hess law. Sabi ng iba, Hess's law. Let's call it Hess's law. So, according to Hess's law, when the reactants are converted into products, the change of enthalpy is the same whether the reaction takes place in one step or in series of steps. So basically, you can get the delta HF of any compounds by just treating them as algebraic equations. No? Okay, so you can get their individual delta HF no, to get using algebra. Okay, so yeah. For example, we have this compound. Let's find the delta HF of carbon monoxide for the reaction C graphite plus 1/2 oxygen producing carbon monoxide. So, hindi binigay yung delta H ng reaction. So, ibig sabihin nun, magde-derive ka. Hindi binigay yung delta H niya. So, magde-derive ka. So, given na yung ating mga related equation, so ito yung related equations which we can manipulate, no? Ma-manipulate mo yan to get this equation. So we have to do something with these two equations so we can get this equation and their corresponding delta H reaction. And later on the delta HF of that. Okay, so gagawin natin, we will treat these two equations as algebraic equation. Babalik-balik na rin natin yan to get this final equation and its corresponding delta H Rxn. So let me do that. So gagawin mo, when you rearrange these two equations, you should pattern it out dito. I-pattern mo siya doon. Okay? So for example, yung carbon graphite nasa left. So that means wala akong gagawin sa reaction na to. So sa reaction 1, wala akong gagawin. Copy ko lang yan. And its delta H reaction will not change kasi wala akong ginawa. Okay? Wala akong ginawa kaya yun pa rin yun. So, ipapattern mo siya dun sa gusto mong equation. How about the equation number 2? So, sa gusto kong equation, nasa right side yung CO. Pero dito, nasa left siya. So, pwede ko gawin. Baliktarin ko yan. Pwede ko baliktarin yan. So, when I reverse my equation 2, what will happen? So, nasa product yung CO gas and nasa reactant. Pati yung oxygen, nasa product side din pala. And then, nasa reactant yung CO2. So, since binaliktad ko yung equation, take note that when you reverse the equation, the delta H will change the sign. So, from negative, it will become positive. And then, after doing appropriate reversions, or actually, pwede mo rin i-multiply yan, no? If in case necessary. So, we can, pag nagkuha na natin yung final form ng ating equation, pwede na natin siya i-combine. So, the combined equation will look like this. So, you have your C graphite plus, papansin mo yung CO2, magka-cancel out. So, wala na yung CO2 sa final equation natin. Kasi meron siya sa left, meron siya sa right. So, kina-cancel yun, di ba? Remember your Gen Chem. Ano pa pwede i-cancel? Oxygen. So, in this equation, you have 1 oxygen. On this one, you have 1/2. So, sobra to ng kalahati. So, if I subtract 1/2 sa both sides, may matitira ditong kalahati na lang. Okay. Producing CO gas. Di ba yun yung gusto nating equation? Ayun o. So since nakuha na natin yung equation na gusto natin, that means we can also get now the delta H reaction. Pwede na natin makuha yung delta H reaction. Okay. So, ano yung delta H reaction? Ipag-a-add mo lang. Kung pinag-add natin yung equations, ipag-a-add mo rin yan. Okay. Kung pinag-add mo, to i-add mo rin yan. So, let me do that. So, negative 393.5, 283. So, pag pinag-add mo yan, you will get negative 110.5 kilojoules. Okay? So, yeah. So, we have negative 110.5 kilojoules for the enthalpy of the reaction. So, we're almost done. So, let me rewrite the equation na nakuha natin. Si graphite, 1/2 oxygen gas, carbon monoxide gas. The delta H reaction now is found out to be 110.5 kilojoules. Now, sabi natin kanina, yung enthalpy of a reaction, that is the products minus the reactants. So, the enthalpy of the products minus the enthalpy of the reactant. Remember this equation. Ayan. So, we will apply this equation sa ating problem. Okay? Let me do that. So, meaning nga, the delta H of the reaction is equal to the moles of the product times their delta HF. So, mole CO, delta HF, CO. Minus yung sa reactants. So, you have the mole carbon graphite, delta HF carbon graphite. Okay. And then also on the reactant, you have moles of oxygen times the delta HF of oxygen. Now, ano yung moles nila? Looking at the equation, the mole of carbon monoxide is just 1. The moles of carbon graphite is just 1. And then the moles of oxygen is 1/2. And also, since we know that carbon graphite and oxygen gas are standard states, meaning ito ay 0, ito din ay 0. So basically, itong nasa right side natin ay 0 na yan lahat. Okay? Kasi 0 to eh. So sabihin 1 times 0, 0. 1/2 times 0 is 0. So ibig sabihin 0 to lahat. Okay? So now, we have delta HF of carbon monoxide gas is equal to the delta H of the reaction. Okay? So, to get the delta HF of the reaction, of CO gas, that is the delta H reaction divided by the moles. That's negative 110.5 kilojoules per mole. Ayan yung final answer natin. Naka-per mole siya kapag delta HF. So that's the final answer. And kung titignan nyo yung table, di ko lang kung nasa table to. Ayun, nasa table siya. Negative 110.5. So ganun yung ginawa nila. Pag hindi given yung delta H ng reaction, you have to do the Hess's law. Okay. So, yan. Medyo mahaba yung process pero kaya yan. So ito, I will give this to you. So this will be added to your group assignment. So gagawin mo, these are three related equation. So, sorry. So these three related equations, i-pattern mo yan. So kapag pinag-add mo yung tatlo, makukuha mo to. So ipa-pattern mo yan. Pwede bali-baliktarin mo yan. Divide mo sa 2, multiply mo sa 2. You can do that, no? So, ito kunwari, ito wag mo ito babaliktarin kasi nasa gilid yung graphite. So, mapansin mo may 2 doon. So, pwede mo i-multiply mo to sa 2 lahat. So, ito nasa left yung H2, nasa left yung H2 doon, at as is yan. Ito, pwede mo to baliktarin kasi nasa right side yung C2H2, ito nasa left. So, baliktarin mo to. Since may 2 na coefficient, dyan, doon, wala. Divide mo to by 2. Okay. So, yun yung idea. Hindi, wag na pala to group assignment. Sinabi ko na yung steps. So, ginawa ko na yung steps. So, i-solve na natin. So, sabi ko nga sa inyo, itong related equations, kailangan bali-baliktarin mo yan so that kapag pinag-add mo yan, makukuha mo tong equation na to. Okay? So, for the first equation, yung carbon graphite nasa left, tsaka may coefficients siya na 2. So, ibig sabihin, I can multiply this by 2. Multiply ko yan by 2. So, I will have 2C graphite. Let me move it a little bit. So, I have 2 carbon graphite times 2 mo kasi 2 yung nakalagay dito eh. So, times 2 mo yan. Plus, magiging times 2 yan, 2 oxygen gas. Using 2 CO2 gas. And the delta H, obviously, will be multiplied by 2. So, ito times 2 natin. 787. Bakit nag-times 2 yun? Kasi sabi ko sa inyo kanina, kung times 2 to, times 2 din yun. Okay? So, yan. Bakit ko minultiply ito sa 2? Kasi nga, naka 2 yung graphite doon. So, times 2 mo yan. Okay. O, what else? Yung H2. Dito yun sa equation B. Doon mo siya makikita. So, for equation B, nasa left side equation. Yung gusto nating equation ay nasa left side din yung H2. So, wala tayong gagawin. Just copy that. So, H2 gas, 1/2 oxygen gas, H2O liquid. So, wala kang ginawa. So, okay mo lang ang delta H. About equation C, sabi ko sa inyo, yung gusto mo, nasa right side. Itong acetylene, nasa right side dapat. So, nasa left side siya dun eh. So, babalik ta rin mo yung equation. So, kailangan yung acetylene nasa right side. So, ito, i-flip mo yan. Reverse this. And what else? Mapapansin mo, dito, 1 yung coefficient niya. Dito, 2. Ibig sabihin, if i-flip ko to, plus, i-divide ko pa to sa 2. Okay? So, indicate ko yan as 1/2 C negative. Ibig sabihin, binaliktad ko. Okay? So, divide ko yan sa 2, then baliktarin ko. So, yung C2H2 nasa product side. 5 halves oxygen, product side. 4 divided by 2 is 2. And then you have 2H2O. Divided by 2 pala yan. So, 2 divided by 2 is 1. Sorry, that should be liquid. Hindi ko makita masyado. This should be liquid. Okay, so yan na. So I did the appropriate manipulation sa ating tatlong equation. Binaliktad ko yung equation C, minultiply ko sa 2 yung equation A, dinivide ko sa 2 yung equation C na binaliktad, no? So kailangan pag pinagsama-sama ko yan, makuha ko to. Okay, so kailangan pag pinagsama-sama ko yan, makukuha ko to. So let's see if tama yung ating derivation. So, i-cancel na natin yung mga pwede i-cancel. Ano yung mga pwede i-cancel? Yung nag-exist sa left side and sa right side. No? So, itong CO2, cancel na yan. Kasi we have 2 CO2 there. You have also 2 CO2 there. So, magka-cancel out sila. What else? H2O. May H2O sa kanan, meron din sa kaliwa. Walang matitira pag kinancel mo sila. Oxygen gas. So sa kabila, we have 5 halves. Dito, we have 2 and then 1 half. What is 2 plus 1 half? That's 5 halves din, di ba? 2.5. Basically, 2.5 to, 2.5 yun. Ibig sabihin, may pwede mo sila ma-cancel out. So now, you will be left with 2C graphite plus H2 gas producing C2H2. Napansin mo, by doing the appropriate algebra, by doing the appropriate manipulation, we will arrive with the same equation to our desired equation. No? So, same yung makukuha natin sa desired equation. Okay? Good yun. Kasi tama yung manipulation. No? Pero kung ginawa mo na lahat, hindi pa rin tumama doon, there's something wrong. Okay? So, this is actually trial and error. No? So, kaya nga, asynchronous tayo today, no? Para makapag-practice talaga kayong lahat, no? So, yun. So, you will have more time, no? To carry out these equations. Solving. Ayan. Basta again, ang goal is kapag pinag-add mo tong mga to, makukuha mo yun. Okay? Ganun lang. Ay, yung delta H pala, nakalimutan ko. For C, delta H, binaliktad ko yon, so may positive, then dinivide ko sa 2. Okay. So the delta H for C will be 1299.4. Pag-add din natin yung delta H, no? Para makuha na natin yung sagot. So, ipag-add ko yan lahat. Negative 787. So, pag pinag-add mo lahat yan, the delta H of the reaction is positive 226.6 kilojoules. Ayan, nice. So, nakuha natin na yung delta H ng reaction natin. And this will be used to get the enthalpy of formation of this. Gagamitin natin to get the enthalpy of formation of that. No? So let me erase this para may space ako. So again, recall that the delta H reaction is the mole times delta HF of the products. Pag-add mo yan lahat, minus the mole delta HF of reactants na. Then, ipag-add mo yan lahat. So, apply natin yun dito sa equation na yan. So, apply natin. Sa product, ano yung mole? On the product, we have 1 mole times delta HF of C2H2. Minus, sa reactant, ipag-add natin yun. We have 2 mole times delta HF of C graphite. I should indicate the state. Ano pa yung nasa reactant? H gas. 1 mole times delta HF of H2. And again, sabi ko nga sa inyo, Carbon exists in graphite form. Yun yung stable form niya. Yun yung elemental form niya. So this is 0. Hydrogen gas, ganun din. So basically, this is also 0. So this time 0, this time 0, 0 to lahat na. So that means we can simplify this. Right? We can simply remove everything on the right side. Kasi nga 0 yon. So we will end up with this equation. Delta H reaction equals 1 mole times this. No? So solving for delta HF of C2H2 give us delta H reaction divided by 1 mole, which is 226.6 kilojoule per mole. And that's our final answer. Let's check kung nandito siya sa table. Ayun o. C2H2, 226.7. Ano ba yung nakuha natin? 226.6. No? Medyo malapit. No? Okay. So, ganun. C2H2, 226.7. Siguro you may ask, no? Sir, paano ko malalaman kung 0 yung elemental state? Paano ko malalaman yung elemental state to begin with, no? So, syempre, ako, alam ko na kasi kung ano yung mga elemental state, di ba? Malamang tinuturo ko itong subject, eh. Pero kayo, I'm sure din nyo pa alam, no? Kaya, ganito. May upload akong material sa inyo, sa Canvas. Ay, Canvas. Hindi pala kayo FEU. May upload ako sa Google Classroom na material, which you can use, no? To get the delta HF values. Okay, so that's the thermodynamic table. Now, let me show you the thermodynamic table. So dito nakalista na lahat ng compounds. Ito yung kaninang delta HF. For example, napin natin yung H2. Ayan. So if you have H2, 0 yan, delta HF niya. Ayan. So you can use this table to look for the delta HF of different compounds. So I will upload this after the recording. Okay. So you may want to use that, no, para ma-solve yung delta HF ng reaction. But you may ask siguro, no, sir, pwede ba doon ko na lang kunin yung delta HF na hindi na ako gumagawa ng S-law? Hindi, kailangan mo ipakita yung solution sa prob set. Kailangan mo talaga gumawa ng Hess law. No choice ka. Okay. Pero again, you can verify your answer sa table, no, na i-upload ko. Okay, so siguro ito na yung group assignment. Sinagutan ko na yung essay. Okay, so this will serve as your group assignment. Ano pala yung desired equation dito? Hindi kasi binigay, no? Ang desired equation natin ay ito. C graphite. Hindi ko na kinukompleto yung graphite, graph na lang nilalagay ko. 2 moles of sulfur, rhombic. Ganyan talaga yung standard state niya, rhombic, no? Ano yung rhombic? Yun yung shape niya, rhombic, no? Malalaman natin yan pag kapag nag-materials. Producing CS2, which is liquid in form. By the way, no? Wait lang, nagulo yung equation dito sa baba. Hindi ko na notice yan, hanapin ko lang uli yung problem na to. May correction dito, edit ko na lang after this video para wait lang. Na-typo pala yun. Hindi ko napansin. Sorry for that. Let me pull out my notes. Okay. So, wala to. So, it should be CS2 liquid, 3O2, and CO2. Yan. So, wala. Na-typo yung gilid. Sorry for that. So, the third equation should look like this. CS2 liquid, 3O2, producing 2 SO2, and CO. Okay, and the delta H is yan. Okay, so again, sorry for that typo. Undesired equation nyo is this one. So, find a way to use all of this. No? Lahat yung gagamitin. So, I want you to find a way, no, to identify, no, the delta HF of CS2. Madaling araw kasi ngayon kaya naririnig niya yung mga aso. Anyway. So again, find a way to use all this equation and you should end up with this and get the value of this. So yan. Okay. So ngayon naman, let's look at another problem. So ito siguro skip ko to na I will give this as your group assignment. So let's try to answer this problem. So we have benzene burns in air to produce carbon dioxide and liquid water. Calculate calculate the heat released in kilojoules per gram of the compound reacted with oxygen. Standard enthalpy of formation of benzene is 49.04 kilojoules per mole. So sabi niyan, ano daw? We need to find, no? Ano yung hahanapin natin? Find the delta H per gram, the delta H reaction per gram of benzene. Okay. Kasi sabi, calculate the heat release, so delta H yun, per gram of the compound reacted with oxygen, which is benzene. So, hanapin daw natin yung delta H per gram nito when reacted with benzene. Ano gagawin mo dito? Wala tayong equation, so gagawa tayo ng equation. So, let's write an equation, combustion equation for benzene. That will be C6H6, oxygen producing CO2 and H2O. Balance tayo. 6 yung carbon. So this should be multiplied by 6. 6 yung hydrogen. This should be multiplied by 3 because, 3 times 2 is 6. Okay. Then what else? Bilangin yung oxygen sa products. 3 times 2, 6 times 2 is 12. 3 times 1 is 3. So you have 15 oxygens on the right side. On the left side, gagawin mo yung 15 over 2. So now we have a balanced equation. So I will not go through the details kasi ni-review na natin yan nung second day ng session. But that is the balanced equation. So now, you have the balanced equation. Kukunin mo na yung delta H reaction. Paano? Remember, given yung mga delta HF. So we need to use them to find the delta H of the reaction. So let me rewrite everything again. So the reaction is this, no? Oopsie, sorry. So we have C6H6 plus 15 over 2 oxygen producing 6CO2 plus 3H2O. By the way, I should indicate the states, no? Benzene is liquid, oxygen is gas, carbon dioxide is gas, H2O is liquid. Hanapin ko daw yung delta H reaction yan. So sabi natin kanina, delta H reaction equals sum ng moles times the delta HF products minus sum ng moles times the delta HF of the reactants. So ngayon, ano yung mga nasa product? CO2 pati H2O. So let me rewrite this. On the product side, I have 6 moles ng CO2 times the delta HF of CO2. I have 3 moles of H2O times the delta HF of H2O minus, sa reactant side, I have benzene, 1 mole, I'm sorry for that. This should be delta HF. Okay, plus 15 over 2 mole delta HF O2. Okay, so yan. So ano alam natin? So this is the equation we will need to get the delta H of the reaction. Okay? Hahanapin mo always yung delta H ng reaction pag ganitong type ng problem. Okay. So, alam natin, oxygen is elemental state. So this is equal to 0. So yung iba, given yan. Okay. So tingin tayo dun sa table na ibibigay ko sa inyo. So let's look at their value dito. So for CO2, hanapin mo yan. CO2. So itong nasa second column yung HF values. CO2. Pasok dito yung CO2. Ayun, CO2. CO2 gas is negative 393.5. Okay. So note ko na lang yan. Okay. So water na liquid, H2O liquid kasi sinabi sa problem. H2O liquid, that is 285.8 kilojoules per mole. And yung benzene, binigay na. Sinabi na sa problem. Okay. So yan, so multiply natin ito with this times this, and 1 mole times that. Okay. Sabi sa problem, that's 49.04 kilojoules per mole. So with this, we can get the delta H of the reaction. So let me rewrite that. So that's 6 mole times, yan, plus 3 mole times negative 285.8 minus, we have 1 mole times this. So as you can see, the moles will cancel out, cancel, giving us the final units of kilojoules. Ay, multiply mo yung lahat. So the delta H reaction is equal to negative 3267.44 kilojoules. Yun, nakuha na natin. Kasi hindi pa tayo tapos. Negative 3267.44 kilojoules. Ang haba ng solutions, no? Pero anyway, so ganun. So we started with the enthalpy of formation nila. So, titingin ka lang sa table na i-upload ko. Multiply mo mga moles nila. Product minus reactant yan. You will get the delta H reaction. Yun na yan. So, hindi pa tayo tapos. Kasi hinahanap is the amount of heat released per gram of this. Okay. So, per gram of this. So, dito yan. No? So, if we have 1 mole of this, ito yung heat. No? What if we have 1 gram of this? Ano yung heat daw? Okay. So, let me erase this. So, gagawin natin, since we are looking for per gram, no? Ganito gagawin natin. Ano ba yung molar mass ng benzene? Okay, so, let me Google that. No? Siyempre, di ko kabisado yung benzene molar mass. 78.7. Lipat ko to sa kabila. Ayan. So, according to Google, 78.11 grams per mole ang benzene. Okay. We can interpret this as 78.11 grams kada 1 mole. Diba? Ganun naman yung molar mass eh. 78.11 grams per 1 mole of benzene. Magagamit natin yan. Bakit? Ganito. You know, delta H reaction in terms of benzene, 1 mole yon. Okay? 1 mole benzene. Okay? So, gusto natin naka per gram to, no? So, gusto natin this is naka per gram. Okay? So, ano pwede natin gawin? So, ganyan. So, you have the delta H of the reaction. Okay. Per 1 mole of benzene. Tapos, yung molar mass niya, we should find a way, no, na yung moles magka-cancel out and yung grams mapupunta sa baba, no? So, basically, you will divide this by the molar mass of benzene. Okay, kailangan mag-find tayo ng way so that the moles will cancel out. Itong mole na to, pati yung mole ng molar mass magka-cancel out. So, let me write that. So, we have negative 3 to 6, 7. Okay, so kilojoule, 1 mole benzene, 2 times, okay. So, dinivide ko yan by the molar mass. So, ito yung nasa baba. 78.11 grams. And then, may fraction dito, pero you can reciprocate that. And then, as you can see, we can just simply cancel them out, no? Giving us the energy per kilogram. Okay? So, that's negative 3267 divided by 78.11. So, the energy of the reaction is negative 41.83 kilojoules per gram benzene. Energy per gram of benzene. Okay? So, yun yung sagot. Daming nangyari, no? Ganun talaga, wala tayong magagawa. So, yan. So, that's the answer. Pero kung given na to, edi shortcut na lang. Ito na lang gagawin, no? Pero kung hindi given tong equation, hanapin mo pa yung equation, hanapin mo pa yung delta H reaction niya. Okay? So, that's how you get the delta H per gram. So, ito, ganun din. Pero binigay ko na yung equation. Basically, hanapin mo delta H reaction na lang. So, please read this problem. Solve for delta H reaction. You know, that's product minus reactants. Okay. So, this times the delta HF neto, 2 times delta HF neto, 2 times delta HF neto, 1 times delta HF neto. Okay. So again, I will upload the table sa Google Classroom after this session. Okay, so now, continue tayo. So let's compare delta U and delta H now. Okay. Kasi sabi natin, di ba, delta U is the Q at constant volume. Ito yung delta U, the internal energy change. And we know that QP, ito yung delta H now. So yan. So delta U is the QV and delta H is the QP. May relationship yan, dalawang yan. Kasi, di ba, we ended up with this equation earlier. Tapos ginawa ko lang binaliktad. Nilipat ko lang yan doon, kaya naging ganito yan, di ba? Okay. Pero again, kunwari hindi ko yung binaliktad. So we have this equation. Okay. So ngayon, we are going now to try to get the relationship between this and that. No? Kasi kung alam mo yung delta U, you should be able to find delta H. Kailangan alam mo kung paano kunin. Kasi again, they ended up with the same equation naman. So they are both related, no? Ang pinagkaiba lang nila is the work. Na yung work lang yung pinagbago nila. Okay? So ngayon, so ito delta U, delta H, wala na tayong problema dyan. So itong last term na to, itong work na yan, we should find a way to know paano natin nakuha to. Okay? Paano nakuha tong final equation na to. So, ganito lang gagawin mo dyan. Recall your ideal gas equation. So, sabi natin, PV equals nRT. And also, recall yung ating Avogadro's law. Ano sabi ni Avogadro's law? Volume is directly proportional to the moles of the gases. No? So, if you have many moles of gases, the volume increases. If you have small moles of gases, the volume is small. Okay? So, ibig sabihin yan, whatever changes in the volume is, that corresponds to the change in the moles of the gas. So, meaning, if we apply that dito, we can say that delta P delta V is equals to delta N RT. So, yun lang yung ginawa natin dyan. So, that's why we said that P delta V is equal to delta N RT. So, we just applied these two equations. And take note that gas yan, the delta N should be the gas, the moles of the gases only. Kasi nga, we are using ideal gas equation. So, ibig sabihin, kapag may liquid dyan, may solid dyan, hindi mo bibilangan yung moles nila. Only yung gases lang. Okay? So, ibig sabihin na, if you know the delta H, you can find delta U. Yan yung sinasabi ko kanina. Pag alam mo na kunin to, which is alam na natin, you can get the delta U. Okay? So, ganun lang. Let's try this. Calculate the change in internal energy. Calculate the change in internal energy when 2 moles of CO, carbon monoxide, are converted to 2 moles of carbon dioxide, given ang delta H. Hinahanap yung delta U. So we know that the relationship is delta U equals delta H minus delta N gas RT. Alam mo na yung delta H, ito na lang problema mo. What's delta N gas now? When we say delta N of the gas, that is the moles of gas in the product minus the moles of gas in the reactant. Ilan ba yung moles ng gas sa product? Dalawa. 2 gas. So, dalawa yan. On the reactant, you have 2 dito and another 1 dito. So, 2 plus 1. So, basically, 3 moles ng gas meron ka sa reactant. So, 2 minus 3 is negative 1. Okay. So, our delta N will be negative 1. Okay, so let's continue. So, let's plug in negative 566 kilojoule minus, sabi natin kanina, this is negative 1 mole. Yung R na gagamitin mo is the energy. And the temperature, of course, in Kelvin. Sinabi kasi na 25 degrees Celsius. Yeah. So, we can solve now for the delta U, the internal energy change. By the way, take note. This one is in joule. Ito naka-kilojoule. So, huwag may susubtract yan. Kasi ito naka-joule, ito naka-kilojoule. Taka ko, iba yung number na lumabas sa calculus ko eh. So, we have to convert this pa. Let me include that conversion dito. Negative 1 mole. Okay, so this is joule, ang final unit na ito. We convert that to kilojoule. Okay, so just divide this by 1,000. So kilojoule to, dapat naka-kilojoule din to. Okay, para hindi tayo magulat sa units. So delta U is negative 563.52 kilojoules. Ayan. So, yan. Pwede na natin makuha yung delta U. So, very easy. So, ganun lang. So, alam na natin kung paano siya kunin. So, for this one, maybe this will be a group assignment na lang. So, I will make it a group assignment. Same for this one. It's also group assignment. Dito wala kayong isa-solve, no? No solving. This is just concept. So, I want you to explain sino sa tatlo dito yung onti yung difference between delta U and delta H. So, you just explain sino sa tatlo. Is it A, is it B, or is it C? Kung pinili mo A, bakit? Kung pinili mo B, bakit? Kung pinili mo C, bakit? Okay. So, yun lang gagawin mo dyan. Okay. So, ngayon, we're almost done. Okay. Punta na tayo sa last part, which is on calorimetry. So, again, ang alam natin na Q pa lang is the QP. Okay. And we know QP is delta H. There are also other ways to measure the Q, no? Or the delta H, no? Or delta U. Okay. There are other ways to solve for Q. Okay. And that can be done experimentally. Naman, papansin nyo, yung mga binibigay sa ating value, as is na yun eh, no? Pero what if I want to do that in the laboratory? You can also do that, no? Okay. So if you want to measure the heat of the reaction, you have to do what's called the calorimetry. Okay. So calorimetry is a measurement, no, of heat changes in chemical processes, or actually even physical processes. So dito natin nakukuha yung mga value na nandito sa table na to. So lahat ng value na yan, nakukuha yan sa calorimetry. Okay. So yan. Kasi you may ask yourself, no? Oh, given yung table, yes. No? Pero saan sila galing? Sa calorimetry po. Okay. So, ganito kasi ang concept ng calorimetry. No? The heat depends on two variables. No? The temperature and the mass of your matter. Okay. So, yung heat, depende siya. Kung mataas yung thermal energy mo, yung inyong temperature, sabihin, mas marami siyang pwede i-transfer na heat. Okay? So, kaya direct yung relationship niyan. The higher the temperature is, the more heat energy can be transferred. Okay? So the higher the T, the higher the Q. The lower the change in temperature, the lower the Q. Ano pa? Mass, no? So if marami kang matter, ibig sabihin mas maraming energy ang kailangan mo to heat them. Okay? For example, sino mas madali pakuluan? Yung 5 ml na tubig, 1 litron tubig. Yung mas mabilis kumulo, yung 5 ml. Okay? Kasi, in terms of mass, mas onti yung heat energy na kailangan mo to increase the temperature of 5 ml water. Compared to 1 liter water, ayun, medyo maraming particles na kailangan initin mo doon. Kaya matagal-tagal yun, no? Initin. Okay. But again, they will boil off at the same temperature. Ang only difference lang ay onti lang yung heat energy na kailangan sa 5 ml na tubig kaysa sa 1 litro. Kaya mas mabilis kumulo yung 5 ml kaysa sa 1 litro. But again, yung temperature kung kailan sila kukulo ay same lang, 100 degrees Celsius. So that is the equation. So Q is the heat, M is the mass, delta T is the change in temp. Whenever you see delta, that's always final minus initial. Kahit anong mangyari, final minus initial. Yeah. Then we have a small letter C here. That is a proportionality constant. Sabi natin, this is proportional to M and T. So if you want to convert the proportionality to equality, you have to introduce a constant. And C is a constant called the specific heat. No? Okay, so that small letter C is called the specific heat. No? And each material will have their own specific heats. No? So depende sa kung ano material gamit mo, may kanya-kanyang specific heat yan. That's why some metals, no, kunwari nagluluto ka, some metals tend to dissipate the heat quickly, some do not, no? For example, may aluminum ka. Okay. Okay. O kunwari, may aluminum ka, tsaka may gold ka. Sino mas mabilis sa kanila mag-release ng heat, no? Si gold, no? Kasi mababa yung kanyang C. Okay? So, ibig sabihin, pag tinanggal mo yung heat source niya, lalamig yan agad, no? Compared to aluminum, malakas yung kaya niya na heat, no? So, marami siyang energy na kaya i-absorb. Kaya matagal-tagal siya bago lumamig. Okay? Ganun din kay iron, na ginagamit natin sa cookwares, copper, ganun din. Okay? So, medyo matagal-tagal sila bago lumamig kasi mataas yung kanilang specific heat. No? Okay? So that's the equation for Q, and from this, we can get the delta U and the delta H. No? So if you multiply M and C, you will get a capital letter C called the heat capacity. So heat capacity is M times the C lang. The mass times the specific heat. Kailan ginagamit itong equation na to? Itong Q equals C delta T. Gagamitin mo itong equation na to, especially if you are doing bomb calorimetry. Okay, so ginagamit ito sa bomb calorimetry. Bakit? Kasi masyadong malaki yung instrument na ginagamit doon, no? The instrument is big, so ibig sabihin hindi mo na siya kailangan timbangin. Masyado siyang malaki. Okay. So instead of measuring the mass of the instrument, we will just get the heat capacity, which is generally given naman. Okay. Pero for small objects, we can use this. Pero kapag bigger objects na, malalaki na yung objects, we use this instead. Okay. Let's try this. A 466-gram sample of water is heated from 850 to 74.6 degrees Celsius. Calculate the Q absorbed in kilojoules by the water given the specific heat of water is this 1.184 joule per gram degree Celsius. Okay. So take note of this. You should remember the specific heat of water. Kailangan kabisado nyo yan. 4.184 joule per gram degrees Celsius. Okay. So, alamin daw natin yung heat na inabsorb ng tubig nung ininit siya from this to that temperature. So, the equation that will be used is Q equals MC delta T. Okay. Kasi given yung mass, ito gagamitin mo, not this. Kasi given naman yung mass. Given kasi yung mass, kaya wag mo gamitin yan. So, let's try that, no? So, Q equals M for 66 grams. Specific heat of water, 4.184. And then, the delta T, sabi ko sa inyo, final minus initial yan. So, mapapansin mo naman kung sino yung final, no? From, ibig sabihin, ito yung initial, to, ito yung final. Okay. Grammar lang yan. Kaya kailangan alam nyo na yan. Okay. So, final is that. Minus initial is that. Okay. So, we can cancel the Celsius. We can cancel the gram, and we will be left with joule as a unit of energy. Okay, so let me just multiply these numbers. Divide by 1,000 kasi gusto ko kilojoules na. The answer is 128.88 kilojoules. Take note, the sign of our Q is consistent with what we have discussed before, di ba? Sabi natin, whenever energy is leaving the system, the energy is negative in value. But if your system absorbs the energy, then that energy will have a positive value. Pag nagpapakulo ka ng tubig, ang nangyayari doon, yung system yung nag-absorb ng energy. So, dapat positive yung makukuha mo, which is positive nga. Okay? So, yan. Whenever you increase the temperature of objects, you are adding heat energy sa kanila. Kaya tumataas yung temperature. Yan. So, kailangan consistent yung sign kasi kung negative yan, baliktad yung temperature mo. How about this one? An iron bar of 869 grams cools from 94 to 5 degrees Celsius. Calculate the heat released by the metal. The specific heat of iron is 0.444 joule per gram degree Celsius. So, given yung mass, so gamitin mo Q equals MC delta T. Plug in lang, so 869 grams, 0.444 joule gram degree Celsius. Temperature, delta T, final minus initial. Kung sino yung katabi ng from, yun yung initial. Kung sino katabi nito, yun yung final. So, the final temp is 5. Initial temp is 94. So, yan, you can see, canceled yung Celsius, canceled yung grams. Let's solve for the Q in kilojoules. Kilojoules na. So, that will be negative 34.34 kilojoules. And again, the sign of our Q is consistent with what we have discussed before. Whenever heat is released by the system, the Q is negative, no? So, ibig sabihin, kung naglalabas siya ng heat, bumababa yung temperature. Ganun nangyayari sa atin, no? Kaya tayo minsan, kalimutan ko yung example ko. Pero anyway, basta ganun, pag bumababa yung temp, naglalabas siya ng heat, no? Ng system. Yung surroundings, iinit yan. Pero yung system, lalamig siya. And okay, so let's proceed. Medyo patapos na tayo. So we have two types of calorimetry which we can use to get the value of Q, experimentally determined to. No? So we have two types of calorimetry. We have the constant volume calorimetry, also called the bomb calorimeter. And we have the constant pressure calorimetry, also called the coffee cup calorimetry. Okay. So yan. So may tinatawag tayong bomb calorimeter. Then we have a coffee cup calorimeter. Okay. So these two devices are used to determine the Q of the reaction. So since mapapansin nyo, we have a constant volume calorimeter. So that means whatever Q you solve here is the change in the internal energy na. So whatever Q you solve here, yun na yung delta U. Okay? So dito naman, whatever Q you solve here, that is the delta H. Kasi nga, constant pressure yan. So if you want to get the delta H from this experiment, you have to use the relationship of delta U and delta H given that delta U equals delta H minus N gas RT. Okay. So you need to use this equation. Okay. So yan, this equation will be used to get the delta H kung ito yung ginawa mo. Ito naman, gamitin mo rin yan to get the delta U kung ito yung ginawa mo. Okay. So yan, this is how we get the energies, the enthalpies, or the delta U in experimental processes. Okay, so isa-isahin natin yan. So we have a bulb calorimeter. Let me zoom in. So this is how it looks like. So in a bomb calorimeter, you have this adiabatic container. So meaning ng adiabatic container, whatever heat outside will not influence the with anything that's inside. No? So kung mainit sa labas, hindi yun mag-interfere with our measurement. Okay? So adiabatic to. So that means this this setup is isolated. No? So we have an adiabatic boundary. Okay. So yun. So whatever heat is in this container, okay, yun yung heat of reaction. Okay. So ano yung tsura niyan? So ganito lang, you have an adiabatic boundary. Then you have water in there. The purpose of water is to absorb the energy. Then you have a small container here at the bottom. Dito mo nilalagay yung materials mo, sample na gusto mo sunugin. Okay. And then when that sample burns, it releases heat to the water. And then whenever the temperature of water increases, that corresponds to the Q of the reaction here. So ito yung ginagamit namin, no, to determine the energy in food products. Okay? So ito yung ginagamit to determine yung gano'ng karaming energy makukuha mo sa fudgy bar, sa Rebisco, no? Kaya sa pagkain, sa manok, no? Basically, lalagay mo sila doon, tapos susunugin sila. Kaya nga bomb, no? Susunugin mo yung mga yan. Parang cremate mo yung pagkain dito. Then, yung heat na napoproduce when the food burns, napupunta siya sa tubig. And ano nangyayari? When the water absorbs energy, it increases its temperature. So, yan. Using our equations earlier, pwede mo makuha yung Q. Okay? So, ang idea dito is that whatever reaction is happening here, mapupunta yun sa tubig ng calorimeter. Or basically sa calorimeter itself, no, as a whole. So, negative sign yung Q ng reaction doon kasi siya yung magre-release. And saan mapupunta yon? Sa calorimeter. Okay? Sa buong setup na yan, doon mapupunta yung heat niyan. Okay, so, ganun lang. And then, you know how to solve for Q. You can use MC delta T o kaya C delta T. Okay. So let's try that. Okay, so let's try this. A quantity of 1.435 grams of naphthalene, a pungent smelling substance used in moth repellents. Ito yung nasa mothball. Okay. Kulay puti na nilalagay sa cabinet, naphthalene. So 1.435 grams daw of that was burned in a constant volume bomb calorimeter. And nung kinombust siya, sabi dito, consequently, the temperature of the water rose from 20.28 degrees Celsius to 25.95 degrees Celsius. If the heat capacity of the bomb plus water was 10.17 kilojoules per degree Celsius, calculate the heat of combustion of naphthalene on a molar basis. That is, find the molar heat of combustion. Okay. So, ang kwento lang dito is ganito. So, ito yung iyong calorimeter. Ayan yung naphthalene mo. Tapos, sinunog mo yan. So, anong mangyayari? Maglalabas yan ng heat kasi sinunog mo eh. Di ba? Lahat naman ng mga susunog na bagay mainit, di ba? Because they release the heat energy. So, yung Q ng reaction na to, mapupunta siya sa calorimeter. Okay? So, we say in equation that negative Q reaction equals Q of the calorimeter. Kasi yung heat na to, mapupunta lang sa calorimeter, sa labas. Kaya ganito equation. Negative dito kasi ito yung maglalabas. Positive to kasi ito yung tatanggap ng energy. Okay? Or, we can transpose this negative sign to that side, no? Pwede naman yan. Pero ito yung gagamitin muna natin for now. Okay? So, yun. So, ito lang idea dito. So, itong mothball mo, nilagay mo doon, sinunog mo. Siyempre, iinit yan. Yung init niyan from here, pupunta sa labas. So, the heat of the reaction will go to the calorimeter. So, negative reaction equals calorimeter. Kung gaano karaming heat energy na nilabas niya, ganun karami yung ma-absorb ng calorimeter. So from this, we can get the Q of the reaction. Okay? Okay. So, sabi ko nga sa inyo, kapag calorimeter ang ginagamit, ang equation na gagamitin mo ay yung capital C delta T. Kasi gaano ba kalaki to? Google ko para makita nyo gaano kalaki yan. Malaki masyado yung bomb calorimeter. Imagine mo, timbangin mo yan araw-araw, no? Papagod ka. Exercise yon. Okay. So, ano itsura niyan? Ito yung itsura ng bomb calorimeter. Yan. Sige, timbangin mo yan. kung di ka mapagod, ewan ko lang na. So, masyado mabigat yan to use the MC delta T. Kaya, C delta T na lang gagamitin natin para hindi na tayo mag-worry sa mass. Okay. Anyway, for every instrument, there is a corresponding heat capacity naman or capital letter C. Okay. So let's continue. Negative Q reaction equals capital C delta T. Yung negative sign, lipat ko na sa kabila, no? So, pwede mo na nilipat na doon. Yan. Okay, so yan. What's the heat capacity of the calorimeter? Ito yung sinabi yun, the heat capacity of bomb plus water. Pag sinabi dyan, bomb plus water, yung calorimeter na yun. Okay, so it was 10.17 kilojoules per degree Celsius daw. Then of course, change in temperature, final minus initial. So this is our final. And this is our initial. So as you can see, in Celsius, magka-cancel. So the heat of reaction is so that is negative 57.66 kilojoule. So that's the heat of the reaction. However, sabi sa problem, on a molar basis. Hanapin daw natin yung heat of reaction on a molar basis. Ano meaning nun? Ito daw, i-divide mo sa moles ng naphthalene. Yun yung meaning kapag molar basis. Ibig sabihin nung kukunin mo pa yung moles na ito. Okay, so let me get the molar mass of naphthalene. Okay. So according to Google, molar mass of naphthalene is 128.17 grams per mole. So kailangan i-divide natin to sa moles ng naphthalene. So mass over molar mass, mole yun. Tapos yung mole yan, divide mo dito. So we can write it as negative 5766 kilojoule divided by mass over molar mass. Okay. Okay. So makukuha mo na yung mole niyan. Okay, take note, the grams will cancel. So the final answer will be negative 5150.02 kilojoules per mole naphthalene. So that's the molar heat of combustion. Okay, so basically pag sinabi molar heat, yung Q mo, divide mo lang sa moles na. So ganun lang. So I want you to do the same process for this one. So this will be group assignment na rin. Medyo dinadamihan ko na yung group assignment para marami kayong i-collaborate na. The process ay same lang. Don't worry. Same lang yung process. Same for this one. Group assignment yan. Obvious naman. Now, let me clarify gagawin nyo dito sa question 2. So kung ano makuha mong Q dito, yung Q, i-divide mo yan sa grams for number 1. Pero dito, sa second one, yung Q, i-divide mo sa moles. Okay? So, heat of combustion per gram. So, that means kung ano yung Q na masolve mo dito, divide mo yun dito. Then, kung tanong naman per mole, kunin mo molar mass niyan. This divided by this molar mass, you will get the moles. And ito, divide mo dun. You will get the heat of combustion per mole of lactic acid. And so, same process lang yan, ha? Yung number 1, marami lang sinabi, pero ganun din yung process nun. Katulad lang din sa kabila. Okay, last one. Nalapit na, thank you Lord. Naantok na ako. Okay, so last one is the constant, this should be pressure. Nakalimutan ko i-edit. So constant pressure calorimetry, also called the coffee cup calorimeter. So ito yung pinakamadali gawin, no? Kasi it doesn't require a special instrument. Kaya nga coffee cup tawag dyan kasi pwede mo to gawin sa baso ng kape. So, ito yung ginawa namin bago mag-pandemic. 2019. Yan. Ang gagawin mo, may styrofoam cups ka lang. Pagpatungin mo lang sila, lagyan mo ng takip. Okay. Yung takip, pwedeng rubber, pwedeng cardboard. No? Tapos yun, maglalagay ka ng thermometer sa loob and then yung panghalo, pwede mo yun is-swirl din. So, depending on whatever is happening inside, may temperature reading ka doon. Okay? So, same process lang din. Yung kanina sa bomb calorimeter, Q reaction negative equals Q calorimeter. Dito naman, negative Q of something or pwedeng reaction equals Q of the solution. Okay? Pwede rin naman ganito. Kunwari, you have a ball. Kunwari, you have a ball na mainit. Mainit yan. Okay. So, ang mangyayari niyan, tas ito, tubig. Ito, water. Pwede mangyari dyan is negative Q ng ball equals Q ng water. Kasi yung init ng ball, mapupunta siya sa water. Kaya, pwede itong equation na to. Okay? So, let's apply that. Again, this is pressure. Sorry for that. So, let's try this. A lead pellet having a mass of 26.47 grams at this temperature was placed in a constant pressure calorimeter of negligible heat capacity containing 100 ml of water. The water temperature rose from 22.5 to 23.17 degrees Celsius. What's the specific heat of lead pellet? Okay. So, ano nangyari dito? Alright, let us visualize. Ito yung dinescribe ko kanina. So, ito yung coffee cup calorimeter. May tubig yan. Tapos, naglagay siya ng lead pellet. Okay. So, ang mass niya daw ay 26.4. As ang initial temperature niya ay 89.98 degrees Celsius. Okay. Tapos, yung tubig daw, the water, ano yung mass niyan? If you have 100 ml of water, ano yung mass nun? 100 grams. Assuming that the density is 1 gram per ml. So, you can do that. Tapos, ano daw yung nangyari? Yung tubig na yon, yung temperature niya ay tumaas, no? So, from 22.5, yun yung initial. Naging final niya is 23.17. Ang pinapahanap ay C ng lead pellet. Before we start, no, isip muna tayo what will happen. Di ba ito mainit to? Sabi dun, mainit siya, 89 degrees Celsius. So, mainit yan. Pag nilagay mo yan dito sa tubig, mag-absorb itong tubig ng init nito. So, i-absorb niya yung heat nito until a point comes wherein equal na sila ng heat. So, since equal sila ng heat, no, that should also give us an idea that their temperatures will be equal as well. Remember, if you have two objects, isa mainit, isa malamig, pag pinagdikit mo yon, magpapantay yung temperature nila over time. Okay? So, ganun yan, no? Ganun din dito. Okay, so ibig sabihin, the final temperature of the lead pellet is also 23.17 degrees Celsius. Same lang sila always ng final temp. Again, same always ng final temp. Yan lang. Tapos ano na. Okay, so with that idea, let me erase this. Okay. Let me erase this visuals. So sabi natin kanina, negative Q ng material, ng ball, which is lead, is equals to Q of the water. Yung lead yung maglalabas ng heat eh. So, negative Q of lead equals the Q of water. Yun yung mag-absorb ng heat. And since hindi naman to bump calorimeter, so we can use the MC delta T for the two. Yung dalawa yung lalagyan mo ng MC delta T. Kasi may mass yung lead, may mass din yung water. So, para sila may MC delta T. M lead, C lead, delta T ng lead. Okay, and then for water, you have the M water, C water, delta T of the water. So since we are solving for this, no, we are solving for the specific heat of lead, we can write this equation as mass of water, C of water, delta T of water, divided by negative mass of lead and delta T of lead. Okay? So, dinivide ko lang para makuha ko ito. Now, what's the mass of water? The mass of water is given as 100 grams. Specific heat ng water. Sabi ko, kailangan kabisado yan. So, specific heat of water is 4.184 joule per gram degrees Celsius. How about the delta T of water? That's final, which is 23.17 minus initial 22.50. Given na yung kanina. So, balikan nyo na lang uli yung video. Kasi binigay ko yung givens doon. Baba, denominator, mass of lead. No? Sabi dyan, 26.47. Okay, and then the delta T of the lead. Okay, okay, so again, I told you, ang final temperature ay same lang. Minus initial temperature for lead, that's 89.98 degrees Celsius. So you can see the grams will cancel, Celsius will cancel, and then we will be left with joule per gram degrees Celsius pa rin. Okay, so paki-plug in na lang sa calcu. So the specific heat of lead is 0.16 joule per gram degrees Celsius. So yeah, that's the final answer. Again, take note of this. Kapag ganito yung case natin, you have a metal, you have water, you have a hot object, you have a cold object, no? Ang final temperature nila parate is equal. Okay? So take note of that. If you have a hot object, you have a cold object, their temperature will be equal. Okay? So yung final temp nila ay always equal. Take note of that. Bakit? Kasi sa isang question dito sa problem set, hahanapin yung final temperature. So, ibibigay ko na sa inyo yun as problem set, no? Para naman, para naman matuto kayong mag-derive. Okay? But again, I will give the answers sa lahat ng questions sa problem set after the deadline. Okay? So, yun lang. Anyway, let's proceed with the next type of question. Again, this is constant pressure. Sorry for that. A quantity of 100 ml of 0.5 molar HCl was mixed with 100 ml of 0.5 molar sodium hydroxide in a constant pressure calorimeter of negligible heat capacity. The initial temperature of HCl and NaO was the same, 22.5, and the final temperature of the mixed solution was 25.86 degrees Celsius. Calculate the heat of reaction. Calculate the heat change for the neutralization on a molar basis. So, ano nangyari dito sa problem na to? Visualize natin para mas makita. So, ito yung coffee cup calorimeter mo. On the left side, you have NaO, 100 ml, or basically 100 grams. 100 grams na gamitin natin. We assume always that the density of water is 1. Tapos ang molarity niya is 0.5 molar. Sa kabila naman, you have HCl. 100 grams din yan. Ang molarity niya ay 0.5. No? Ano yung molarity? Sana naalala nyo sa Gen Chem. Molarity is the moles per liter. No? Moles of substance per liter of solution. We denote that as capital letter M. But I assume you know that. Gen Chem kasi yan. Pero if not, ayan siya. Okay lang naman kung di alam. Ayan yung unit niya, mole per liter. So, ayan. So, you have HCl, you have NaO. Tapos, ang nangyari is ganito. Nang pinaghalo mo sila, syempre magiging 200 grams yan pag pinaghalo mo yan, di ba? Solution. Makagawa ka ng solution. Ang mass niya ay 200 grams. No? Tapos, ano nangyari? Yung temperature nag-increase to 25.86 degrees Celsius. Calculate for the Q of reaction daw. Okay. Saan nanggaling yung Q ng reaction dito? Kasi ganito. Yung particles ng NaO pati HCl, pag nagsama yan, they react in a process called neutralization process. So, ibig sabihin, the reason why the temperature here increase is because of the reaction. So, the Q of the reaction of the molecules is transferred to the solution. Okay? So, yung init ng mga molecules kapag sila nag-react, they are being transferred sa solution. And as a result, yung solution, tumataas yung temperature. Okay? So, we can write that as negative Q reaction equals Q ng solution. Similar with the bomb calorimeter. Pero sa bomb calorimeter, yung right side ay Q calorimeter. This time, anong nangyari lang? Pag pinag-react mo itong dalawa, umiinit yan. As a result, tataas yung temperature ng solution. Okay? So yan, tataas yung temperature niya. So, negative Q reaction kasi siya yung maglalabas ng heat papunta sa solution. Positive for the solution. Kasi siya yung mag-absorb ng heat. Okay? So, we can continue. So, given that equation, negative Q reaction equals Q solution. We know that the solution, the Q of the solution can be expressed as mass solution, C solution, and delta T of the solution. Lipat mo na yung negative sign doon. Yung mass ng solution, given na yun, no? Kasi sabi natin, ito, 100 grams yan if we assume that the density is 1. To then, 100 grams yan if we assume that the density is 1. So 100 plus 100, 200 grams. No? Now, what is the specific heat? Hindi sinabi. Pero ang idea dito is gawa sila sa water, pati molecules ng HCl, pati nao. So, kapag hindi sinabi kung ano yung specific heat ng solution, gamitin mo na lang yun sa water. Okay? Use yung nasa water, which is 4.184 joule per gram degrees Celsius. And the delta T of the solution is the final temperature minus the initial. So the final temp is 25.86 minus the initial. Ang sinabi dyan, same sila na 22.5. Okay, so they have the same temperature, 22.5 degrees Celsius. You can see the grams and the Celsius will cancel, giving us the heat of the reaction equal to gawin ko ng kilojoules, no? Negative 2.81 kilojoules. No? So that's the heat of the reaction. Yun yung heat involved in increasing the temperature from this to that, no? When you mix the solution. Pero ang tanong sa atin is molar basis. So kukunin mo yung moles ng substance. Again, paano mo makuha yung moles? Sabi ko sa inyo, yung molarity. That is mole per liter. Ibig sabihin nun, mole is the molarity times the liter. O given yung molarity, given yung volume ng solution, you can multiply that. You may ask siguro, Sir, alin dyan gagamitin ko? Ito ba o ito? Any of them, no? Any of them will do. Basta isa lang yung gagamitin mo. Okay? Okay. Kahit sino pwede. Pwedeng ito, pwedeng ayon. Okay? So, pwedeng tig isa. At ito, yun, pwede rin ito. Sir, you may ask siguro, paano po kapag magkaiba yung moles niyan? Pag magkaiba yung moles niyan, gagamit tayo ng limiting and excess reagent. Which is hindi na natin gagawin. Okay? Huwag na tayo mag-limiting excess reagent, nahihirapan lang kayo. So ngayon, gagawin lang natin, same lang sila. Same lang sila ng moles. Okay. So yun. So ibig sabihin, kahit alin dyan, pwede gamitin. So let's get the moles. No? So mole is molarity times the volume. 100 ml is 0.1 liters. Okay. So this will be 0.05 mole. Okay. 0.05 mole. So you divide the Q of the reaction with that. So negative 2.81 kilojoules, 0.05 mole. So the Q of the reaction will be equal to negative 56.2 kilojoules per mole. Always may per mole kapag molar basis. So that is now the heat of the reaction. And this heat of the reaction, take note, this refers to delta H na rin, no? Kasi constant pressure. Okay? So yun yung two ideas dito. So if you have a hot object, cold object, ang final temperature ay equal. So if pinapahanap yung final temperature, just do some algebra. Algebra nyo na lang yan. I will leave that to you as an activity. Madali lang naman yun. Kasi college na kayo, marunong na kayo mag-algebra. So, algebra lang. Then, kapag ganito naman, chemical reaction, ganito yung format niya. Q reaction equals Q solution. And you can express this as MC delta T. Ang mass ng solution is yung pinagsamang volume nila, pinagsamang masses nila. Sino ang solution? Pag di sinabi, di water ang gamitin. O delta T, sasabihin naman yan. Kung gusto ay molar basis, then you divide this by the moles. No? Kapag molarity ang binigay, to get the moles, that is molarity times the volume in liters. Ayun. So yeah, we're done. No? So I will leave this to you as your group assignment. So these are the group assignment. Ayan, pinapahanap dito, final temperature. Okay. So exciting yan. You have to derive. No? Mag-derive kayo dito. Ito naman, this is similar with the previous question. Okay, so this is similar with the previous question. Ito naman, group number, question number 3. Yeah, this is also similar with the previous question. And these are other problems. So these are additional group assignments. Ang dami, no? Ayan, pasensya na. Marami. Kaya nga, in-extend ko deadline kasi dinamihan ko yung assignments nyo. Anyway, the idea is that para ma-practice kayo. So that pag nag-quiz kayo, madali na lang. Okay? So ito, bigyan ko kayo idea. This is insulated container. Ibig sabihin, bump calorimeter yan. Ito naman, burned-in calorimeter. Ibig sabihin, bump calorimeter din to. Ito, pinaghalong water. So ito ay coffee cup calorimeter. Okay? So yan. So that will be all for the calorimeter. Again, let's take note of our schedule. So natapos natin lahat today. Hopefully may nasundan naman. Medyo mahirap lang to sa umpisa, pero pag inulit nyo uli yung video, madali na lang siya. So yan, ulit-ulitin nyo na lang yung video until mag-gets. Then you can ask me naman. So yan. So take note of our schedule. So today is Wednesday, 5/5, Shopee sale, Lazada sale. Okay. So we are on 5/5 ngayon. So ito tayo. So na-discuss natin na lahat ng nasa first part. So on Saturday, we will not meet. Magkakaroon kayo ng quiz. Again, yung quiz, wala siyang deadline. I mean, ang deadline yan is end pa ng semester. Pero kung kaya nyo na mag-take sa Sabado, sige, mag-take na kayo. Okay. Yung prob set, yung deadline yan, minove ko next Wednesday. By the way, this next Wednesday, I'm not really sure kung asynchronous ulit tayo. I'm not really sure kung ano may yung schedule. Kasi apparently, my schedule was moved dito sa Lasal na urong yung exam schedule ko. Kaya, I don't know if dito yun tatama. Wednesday kasi klase ko dun eh. Ayan. So, I will update you if mag-synchronous tayo dito or asynchronous. Okay? So anyway, may onti lang naman di-discuss dyan. So malapit na tayo mag-midterm. Okay? So that will be all for our session today. Thank you, and I hope na you learned something. I'll see you again next time. Stay safe and don't hesitate to message me if you have any questions. Okay? So thank you and bye-bye.